You've already seen some of these tricks. I asked you to make your inputs zero mean and equal variance earlier. It's very important for SGD. I also told you to initialize with random weights that have relatively small variance. Same thing. I'm going to talk about a few more of those important tricks, and that should cover all you really need to worry about to implement SGD. The first one is momentum. Remember that at each step, we're taking a very small step in a random direction, but that on aggregate, those steps take us towards the minimum of the loss. We can take advantage of the knowledge that we've accumulated from previous steps about where we should be headed. A cheap way to do that is to keep a running average of the gradients and to use that running average instead of the direction of the current batch of the data. This momentum technique works very well and often leads to better convergence. The second one is learning rate decay. Remember, when replacing gradient descent with SGD, I said that we were going to take smaller, noisier steps towards our objective. How small should that step be? That's a whole area of research as well. One thing that's always the case, however, is that it's beneficial to make that step smaller and smaller as you train. Some like to apply an exponential decay to the learning rate. Some like to make it smaller every time the loss reaches a plateau. There are lots of ways to go about it, but lowering it over time is the key thing to remember.